All right, notes on word problems. We're going to do 1, 3, 5, and 6. 1, 3, 5, and 6. And your homework will be 5 problems. So the next worksheet is long, but we're only going to assign 5 of them. So don't, if you're the work ahead person, don't work too far ahead. All right, how much money must be deposited in an account that pays 9% compounded monthly to have a balance of $3,000 after 3 years? Okay, so compounded monthly, the after is the pre, and continuously is the PERT formula, but monthly is, I've got to divide the rate by 12, but then raise it to the NT, right? So, because I'll be doing 12 times however many years there are, that's how many times we will compound that money. Okay, so we started with, how much money to start with? We don't know, that's what we're looking for. We want 3,000 at the end. Don't know what we're starting with. Rate is 0.09 over, monthly means we'll divide by 12, and then raise that to the 12 times 3. Right, so 3 years monthly means 36 compoundings, I guess. But you don't get to 9% each time. You get 9% divided by 12. Okay, so I think I just want to put all this in the calculator. 3,000 divided by all of this. Just going to go ahead and change that to 36. Okay, be careful with parentheses. I could do the fraction bar thing. 1 plus 0.09 over 12, all to the 36. Am I expecting a number more than or less than 3,000?
Less than.
Less than, right? I started with less than 3,000. 3 years later, I've got 3,000. So if I started with 2292.45. Again, we're not like super experts on how much money we should expect, but that seems like a reasonable answer to me. Right? It's definitely less than 3,000. It's not negative. It's not like $1 turns into $3,000, so that seems reasonable. All right, number 3. The value of a $22,500 automobile decreases 20% per year. So what should I multiply by to get its new value? 0.8, right? It loses 0.2, which means I should multiply by 0.8. You can do 1 minus 0.2 if you want to know where that came from, but 22,500 times 0.8 to the t or x, however you want to phrase that. That's my formula for, I guess, v for value. Okay, after 1 year, 22,500 times 0.8. Down to $18,000 after 1 year. After 8 years, so I could do times 0.8, times 0.8, times 0.8, but that would be raised to the 8. Oh, we're down to $3,700, our nice new car. When will it be worth only $2,000? So 2,000 equals 22.5 times 0.8 to the t. Okay, here's the real reason we worked this problem, or I picked this problem, because I got to solve for t. What do you think we should do first? I don't want a natural log yet. I will need to do that eventually to get that t out of the exponent. Move the 22.5 over. Right? Don't multiply those because that's got an exponent on it. I can't do that. Let's divide by 22.5. In fact, and again, I'm just going to wait till the very end to put this in my calculator. Because 2,000 divided by 22,500 is going to be some weird decimal, and I don't want to mess with that. Now, Cooper, what would you like to do? Natural log both sides so that that exponent can become a coefficient. And now we're almost there. Divided by natural log of 0.8. So you're going to have this weird expression in the calculator. Careful with parentheses. And like, who gets the natural logs? Any guesses on how long it's going to take to get to 2,000? Is it going to be more than 8 years or less than 8 years? More. So already it's more than 8 years. I don't know how many more, but let's see. Natural log 2,000 divided by 22,500, close parentheses, divided by natural log of 0.8. 10.846. 847. That seems reasonable, right? I knew it had to be more than 8, but it's still got some value, so I'm not expecting, 500 years or something crazy. Number 5. When it is compounded continuously, here it just gives you the formula. The formula is A equals PERT, where R is the interest rate, P is the principal, T is time. You deposit $2,000 in an account that pays 3.5% interest. Find the amount in the account after 5 years if it is compounded continuously. So there's our magic word to use the PERT formula. Okay, find the amount after 5 years. So we're looking for the after. We know the pre. This is an easy one, right? No solving involved. Just grab a calculator and type it all in. That's the kind we like. $2,000 e to the 0.035 times 5, 2382. Again, we are not at all experts at like guessing how much money we'll have after 3 years or 5 years, but that seems reasonable. Especially 3.5% is not very much. So we got a little bit more money than we started with. Right? Certainly it would be more than 2,000 if it was, if our answer was 5,000 or 10,000 or a million. Hopefully we'd realize, wait a minute, something doesn't seem right there. Like if you made the mistake of forgetting to change the decimal and just used 35 or 3.5, I guess. Hopefully you would realize that that doesn't seem realistic, right? And there's no bank that 5 years later you put in $2,000 and 5 years later you've got $79 billion, $80 billion. If you find that bank, please let me know. I will invest some of my money there. I'll invest all of my money there, is correct. I might not invest all of it there because I would be worried that something is not right. Clearly, that bank is messed up.
Even if we invest
right. So if you invested $10 instead of $2,000 for 5 years, that's still, you're still pretty good. That is $400 million. Think you could make it in life with $400 million?
I think so.
I hope so. I would hope so. Number 6. If money invested in an account paying 4.5% interest, compounded continuously, there's our magic word for the PERT formula. How long will it take for the investment to double? So how is this problem different than number 5?
It doesn't give us an amount of money that we're putting in.
Okay, it doesn't give us the amount of money we're putting in, and we were looking for time. How long will it take? Oh, I don't know A, I don't know P, and I don't know T. Well, what the heck am I supposed to do here?
Could we make up a P?
Yes.
Because if it's doubling, it would take that amount of time to double anyways.
Correct. So Cooper's idea is let's just make up a P, and then the time to double, it doesn't really matter how much we start with, whether we start with 100 or $1 or $400 million. Like, it doesn't matter what you start with. It's going to take the same amount of time to double it. So you got a number you'd like to start with, just make life easy?
Yeah, 10.
Okay, 10, which means we'll eventually have 20. What's the first step you're going to do to solve this for T?
Divide by 10.
Divide by 10. And what do you get on the other side? 2. And so that sort of confirms what Cooper thought, is like it doesn't really matter what you start with, because that first step you're going to divide with that and end up with 2 right there. Whether you started with $1 million or whether you started with 2 cents, you're going to end up with 2. What would you like to do next? Natural log both sides. So natural log of 2 equals 0.045t times natural log of e.
Which is just 1.
Good, which is just 1. If you forget that and you type it in the calculator, fine, your calculator knows that the natural log of e is 1. But hopefully most of you would realize, wait a minute, that's just 1. And now all I have to do is natural log of 2 divided by 0.045. Oops. So 15.403 years. $15 to double your money.
How many dollars now?
4.5%. Yeah. Oh, yeah. Okay, on to this next worksheet is another one that's got a lot of word problems. We don't want to do a lot of word problems. We only want to do numbers 16 through 20. We only want to do numbers 16 through 20. You may not even want to do that many, but I want you to do 16 through 20. And the hint is the one word problem on the test is found within 16 through 20. Right? I'm not going to tell you which one it's closest to, but at least narrow down your narrow down what you got to worry about. And all of those are solved for t, so it's going to be a solve for t problem. But exactly which one it is, it'll be one like 16 through 20. And then I'll just say this, the review. I'm just going to say it's the odds. That's tomorrow's assignment. If you need to work more of them to make sure you understand, then by all means work more of them. But I'm just going to say the odds. That way it'll go a little bit quicker for you. I know there's still AP testing going on, so trying to dial it back a little bit here. So today's worksheet 16 through 20. Tomorrow's assignment is the review, but just the odds, and then we'll test Wednesday, Thursday. And if you've got AP testing in there, don't worry about it. We'll fix it on Friday.